This is example 2-14, where we're trying to find out how deep a raft would sink. So we have this raft here. It says that it has a mass of 2 megagrams and has 4 of these floats. We have a cross section through 2 of these. And each of those floats has a mass of 120 kilograms and a length of 4 meters. And so how far is that float going to sink in? So of course we know that if we have 4 floats, then the entire weight will need to be supported, a quarter of the entire weight of the platform will be supported by each of the floats. So we can say the weight of the entire thing, or the weight that each of them will support, will be 1/4 times the weight of the mass of the float. So 2 megagrams times g, and then of course plus however much each of these float weighs, 120 kilograms times g, and that is then 1/4 times 2 times 10 to the 3 kilograms times 9.81 meters per second squared plus 120 kilograms times 9.81 meters per second squared. And that gives me a value of 6,082.2 newtons. Right, so this is the weight that each of these floats will have to support. Now, if we think about this, right, if we do kind of a think about a free body diagram through one of those floats, something like this. Let me draw a better circle here. All right, then we'll know, because it's sinking into the water, we'll have our FB, our buoyant force, and of course we have the weight that we just calculated. Based on this, we can of course easily see that our weight has to be the same as our buoyant force, right? Otherwise it would sink. We know from our buoyant force that's just the weight, the volume of the submerged object times gamma. So we now have to find is, we need to find what the submerged volume is, so we can calculate the buoyant force. So let's do another sketch here. All right, so we have our half circle, and then we have the top part on here. We know that the radius here is 0.25 meters. And now we want to know what the height is here. Or if we say that maybe our sinks in to be somewhere, the water level will be there. Right, so that'd be the height. Of course, we also know that overall the width of this would be 0.5 meters. Right, 2 times r. All right, based on that, we can go ahead and calculate what our volume would be. Right, our volume would be the half circle times the length. Right, so we can say VF. Well, we can say the length for all of it, so 4 meters, and then times the half of the circle, so we'll just say pi over 2 times the radius, which in our case is 0.25 meters squared. So that would be the lower part, and the upper part, of course, is just 0.5 times h. So if we pull that in, pull out the 4 meters and work with all these numbers here, then we get 0.125 pi meters cubed plus 2 meters squared times h. So here we have our h. So now we can go back to our equation up here, right, where we basically said that the weight is equal to the buoyant force. Well, that means the weight has to be equal to the submerged volume times gamma. So we can say W is equal to VF times gamma. Figured out what VF is right there, so we can say that be 0.125 pi meter cubed plus 2 meter squared times h, all this times gamma. All right, so now if we want to solve this for h, right, that's the thing that we're looking for. So then we just multiply this out, so we get 0.125 pi meter cubed times gamma plus 2 meters squared times h times gamma. That means 2 meters squared times h times gamma is equal to W minus 0.125 pi meter cubed gamma, right? Basically, we took this term, brought it to the left side. And then if we divide through, then we get h is equal to W minus 0.125 pi meter cubed times gamma divided by 2 meters squared times gamma, which means if we then plug in numbers, where we calculated our W a little earlier was 6,082.2. So we get 6,000, that was one too quick, 82.2 Newton minus 0.125 pi meter cubed times 9,810 Newton per cubic meters divided by 2 meters squared times 9,810 Newton per cubic meters. Oh, let's put this on the next line here. Give ourselves some space. That is 0.11365 meters. If we round this, 0.114 meters, or 114 millimeters. So what does that tell us? Right, that tells us, if we think about our float here, then we know that there's going to be a distance of 114 going from the from kind of the center of this upward. Now, if we knew how tall this entire thing is, then we can subtract it, but I don't think that's necessarily given in this problem.